So chapter 3, the gases and the kinetic molecular theory. So previously we have discussed on the three states of the matter, okay, in which the first state is the solid state. Okay, this is the figure that shows how this substance in a solid state, when if we zoom in, we look at to the solid molecules, they are close together in a regular array and they do not move around one another. Okay, if let's say they have a high energy, they just vibrate at their own place. As compared to the second state of the matter, which is a liquid, the molecules are close together, however, they can pass around each other. And lastly, the third state of matter is a gaseous state. Okay, this is when if we zoom in, okay, in a gaseous sample that we have, the molecules are far apart from each other, they can move freely, and they will fill all the available space that they have. These are the criteria of the molecules that is in a gaseous state. So when we talk about the gas, okay, it is always expressed in terms of its pressure. So pressure is defined as the force acting on an object per unit area, and the SI unit for the pressure is Pascal or Newton meter -2. And if we want to measure the atmospheric pressure, the instrument that we use is the barometer. Okay, as compared, if we want to measure the temperature, then we'll use thermometer. These are several units that we can use, and we have to be able to convert the unit from ATM, the unit of the pressure, from ATM to the Pascal to the millimeter mercury, torr, and nm -2. Okay, and also we have to be able to convert from bar to Pascal. So please memorize these conversion factors. Okay, get familiar with. Okay, and you need to be able to convert the pressure in any of the units that is given. So let's refresh back on the volume unit. Okay, 1 liter is actually equal to 1 dm cube. Okay, as I said before this, 1 cm cube is equal to 1 mil. So 1 liter is equal to 1 dm cube, 1 mil is equal to 1 cm cube. As for the temperature, is always expressed in Kelvin. So before we start any calculation that involve temperature, please make sure that you convert it to the Kelvin unit first, in which Kelvin is the degree C value plus with 273.15. Then we'll get the temperature in the Kelvin unit. The first gas law that we want to discuss is the Boyle's law. We have learned this in our secondary school. So the Boyle's law said that at the constant temperature, the volume that is occupied by a fixed amount of the gas is inversely proportional to the applied pressure. So what we have to focus in this is the temperature is constant, amount also constant, fixed amount here. And at this time, the volume is inversely proportional to the pressure that was applied to the gas. So it can be expressed in this mathematical expression, V is inversely proportional to the pressure. If we convert this proportional symbol into equal symbol, then we'll put K as a constant here, and we rearrange K and make it as a subject, so constant is equal to PV. Or if V is a subject, so V is equal to K, or the constant over the pressure. Therefore, through Boyle's law, we know that we can conclude that when the V of the gas increases, P of the gas decreases. They are inversely proportional. It can be represented by these two containers when we have a gases. Okay, this is the initial pressure exerted. Okay, and we can observe that the volume occupied by the gas, okay, is greater, and it will make the pressure in this container become lower as compared to if we compress the gas. Okay, it makes the volume of the container decreases. Okay, and the pressure in this container or the pressure of the gas become higher than before. This is how we choose the Boyle's law. How when the pressure is increases, then the volume decreases. While when the pressure decreases, volume will be higher. Boyle's law. So that if we have a different pressure and different volume of the gas, okay, we can use this equation P1V1 equal to P2V2. So this is the initial pressure, initial volume is equal to final pressure multiplied with the final volume. And if we plot a graph of the pressure versus volume of the gas, we'll get this curved graph, pressure versus volume, and it shows that the pressure is inversely proportional to the volume of the gas. Let's look at today's example. Okay, when we have a chlorine gas that occupied a volume of 946 ml, okay, with a pressure of 726 mmHg, calculate the pressure of the gas if the volume is reduced to 154 ml and the temperature is constant. So let's highlight all the important informations in the question. Okay, we have 946 ml. This is the V1. And then 726 mmHg or millimeter mercury. This is our P1. And then the volume is reduced to 154 ml, means that 154 is the V2. So we have to calculate P2. This is what the question wants. So make it as a subject. So finally, we'll get the final answer is 4,460 mmHg. So the second gas law is the Charles law. So the Charles law said that at the constant pressure, the volume that is occupied by a fixed amount of gas is directly proportional to the temperature. So let's look at to the information that we have to take note on this Charles law is the pressure is constant, amount of the gas also constant. So this time volume is directly proportional to the temperature. Means that if we increase the volume, then the temperature increases. Or if we decrease the temperature, means that the volume decreases. So it can be expressed mathematically with the V directly proportional to T. And if we change this proportional symbol to equal symbol, then we know that V is equal to KT or K is equal to V over T. So the equation that can relate the volume of the gas at different temperature is V1 over T1 equal to V2 over T2, in which V1 is the volume initial, T1 is the temperature initial, V2 is the final volume, and T2 is the final temperature. And remember, as I said just now, okay, the temperature must be in a Kelvin unit. So the relationship between volume of the gas and also the temperature can be graphically shown, okay, by using this diagram, okay, volume versus temperature. And we have this linear graph directly proportional, means that when the temperature increases, at the same time the volume also increases. So example on the application of the Charles law, okay, when we have a carbon monoxide gas occupies 3.2 liter at 125 degrees C. So this is the first information that we have, 3.2 liter. And the temperature is 125 degrees C. This is the V1, 125 is T1. Then we have to calculate the temperature at which the gas will occupy 1.54 liter. So this is our V2 if the pressure remains constant. So we'll use the equation that is given. Okay, take out all the information that we have. V1 3.2 liter, V2 1.54 liter. Okay, and then the temperature converted to Kelvin unit. This is the initial temperature, so 398.15 Kelvin. Okay, and we know that when we have two different volume and two different temperature, we'll use this equation V1 over T1 equal to V2 over T2. So just plug in the value and make T2 as the subject. Okay, conversion, and we'll get our T2 is equal to 192 Kelvin. If we combine the Boyle's law and Charles' law, okay, in which Boyle's law is the V inversely proportional to P, Charles' law is the V directly proportional to T. So we'll get the equation of the V directly proportional to T over P. Okay, this P is supposed to be here below T. Okay, so that if we change this proportional symbol to equal symbol, we'll get V equal to K T over P. However, if we make K as the subject or the constant as the subject, we'll get the equation PV over T equal to K. So that if let's say we got a question when we have two different pressure, two different volume, and two different temperature, we'll use this equation P1 V1 over T1 equal to P2 V2 over T2. Example is given here when we have a balloon that contains 5.41 dm cube of helium gas. Okay, see, this is volume. At the temperature of 25 degrees C, temperature, and the pressure is 101.5 kilopascal. Suppose the gas in the balloon is heated, so now the temperature of the gas increases to 35 degrees C from 24, and the new pressure is given as 102.8. The question asks us what is the volume. So we'll use the previous equation that is given to solve this. So make this as your homework. The third law that we'll discuss is on the Avogadro's law. It shows the relationship between volume and also the amount of the gas. So Avogadro's law states that when the pressure and also temperature is fixed or constant, volume of the gas is directly proportional to the number of mole of the gas present. Okay, so the volume directly proportional to the number of mole or the amount of the gas present. This is Avogadro's law. So it can be expressed as V directly proportional to N. Or if we convert this proportional symbol to equal symbol, we'll get V is equal to K N. Or if we make K as the subject or the constant as the subject, we'll get K equal to volume over N, the amount or the number of mole of the gas. Okay, this is when the pressure and the temperature is fixed or constant. So if let's say we have two different volume and two different amount of gas, we'll use this equation V1 over N1 is equal to V2 over N2. This is because V over N is equal to constant. So V1 over N1 is equal to constant. V2 over N2 also equal to constant. Okay. So if we consider this reaction, okay, the production of the ammonia, okay, sorry for the arrow, it's supposed to be here. Okay, the production of the ammonia from hydrogen and nitrogen. So from this equation, we know that 3 mole of the hydrogen react with 1 mole of the nitrogen to produce 2 mole of the ammonia. Therefore, their mole ratio are 3 to 1 to 2. Since that, Avogadro's law said that the amount is directly proportional to the volume. So if let's say 3 mole occupy 3 liter volume. If let's say 3 mole occupy 3 liter volume, 1 mole will occupy 1 liter volume and 2 mole will occupy 2 liter volume. It means that the mole ratio will be the same as the volume ratio, which is 3 to 1 to 2. Okay, and remember this is occur when the temperature and the pressure is constant. Let's look at the gas behavior at the standard condition. The standard condition is also known as the STP, in which it stands for standard temperature pressure. So the standard temperature is 0 degrees C, or in Kelvin unit it is 273.15 Kelvin. As for the standard pressure is 1 atm or 760 torr. So at this condition, 0 degrees C, 1 atm, the volume that is occupied by 1 mole of the ideal gas is called as the standard molar volume. Okay, if we have 1 mole of any ideal gas, okay, at this 0 degrees C and also 1 atm, we call it as the standard molar volume. Why standard? Because it is at the standard condition or STP. And the standard molar volume for any ideal gas is 22.4 liter. You can refer to figure 5.9 in the textbook. Okay, so any gas, okay, with any molar mass, as long as they are at STP, they will occupy the same volume. Okay, so if you have 1 mole of it, it will occupy 22.4 liter. If we have only 0.5 mole of the gas, it will occupy half of this, which is 11.2 liter. Okay, it is represented in this figure when we have 3 different gases. We have helium, the purple gas, we have blue tank for nitrogen gas, as for the red tank for the oxygen gas. If we look at to the amount, here is 1 mole, nitrogen also 1 mole, oxygen 1 mole. Their pressure are the same, which is 1 atm, 1 atm, 1 atm. This is the standard pressure. And the temperature of all gases are 0 degrees C, we can observe here. And the volume that is occupied by each gases is 22.4 liter. Okay, even though they have different molar mass, you look at here, and also different density. Look at to the example that is given. What is the volume of the hydrogen gas that is obtained from the reaction of 6.5 gram of zinc with the dilute H2SO4 at STP. Okay, so this is a reaction between zinc and also sulfuric acid. So when we get a question, of course, that we have to come up with the valence equation. So the equation is 1 zinc solid plus 1 H2SO4 aqueous. It will produce zinc sulfate aqueous and H2 gas. Their mole ratio is all 1 to 1 to 1 to 1. So the first step is we have to calculate the number of mole of the zinc that is present, which is from 6.5 gram, okay, over its molar mass, which is 65.39 gram. We'll get the number of mole of zinc that is reacted is 0.1 mole. Okay, and then from the mole ratio, we know that 1 mole of zinc will produce 1 mole of H2. Therefore, the number of mole of the H2 that will be produced is the same as the number of mole of zinc that is present, which is 0.1 mole of hydrogen gas. Since that the reaction occur at STP, which is 0 degrees C and also 1 atm, so 1 mole of any gases will occupy 22.4 liter or 22.4 dm cube. So since that we have only 0.1 mole of the H2, it will occupy 2.24 dm cube volume.